Hello all, I am Aswani, Assistant Professor, Department of AIML at MLR Institute of Technology. In today's session, we are going to learn what are the design issues of artificial neural networks. In the previous sessions, we have already seen what is the artificial neural network, what are the different types of artificial neural networks, single layer, multi-layer, and radial basis functions also we have seen in the previous sessions. In the today's session, we are going to learn various design issues of artificial neural networks. Let's see. So, some of the design issues that are usually encountered while designing the artificial neural networks, those are data representation, network topology, determination of network parameters, and training and validation, and also testing. Let's see the first one, data representation. So here first, to learn neural network, any model, it required some data. The data in the form of zeros and ones. Let's see. Data representation is a design issue that is a problem specific. Generally, artificial neural networks uses continuous attributes. Hence, symbolic attributes need to be encoded into continuous forms. For example, if you write a red, blue, green like this, then it won't understand what is red, blue, green. So we need to convert this into the zeros and ones values. For example, like this 1, 0, 0, 0, 1, 0. In such a way, in this order, we need to feed the data to the neural network. Then only it is able to learn that data. Next, each value is normalized to scale its values between 0 and 1. How we have fed the data into the neural networks, that is in the between 0 and 1s using the following formula. If, for example, if you are training something age, for example, any disease finding, the age we need to give. For example, the age is in between 0 to 100, 1 to 100 like that, and height, for example, the height parameter is some 1 to 2, for example, scale like that. Then there is a huge difference between this height range and age range. So to reduce this type of differences, if you fed the same to that model, the neural network, then it will may give the wrong result. So it will give inaccurate result. That's why we need to scale this as a normalized values using this formula. For example, if you take age, the values are 30 to 100, for example. If a heart attack, for example, then the age is in between 30 to 100, then 55 is the threshold. Then we need to substitute these values into this formula. Whatever result is there, that we will feed the neural network. Okay, so xj is 55 and minimum value is 30, min j is 30 and max j is 100. So we will substitute this value and we will get some 0.357 in between 0 and 1. So these type of values only we will feed to the neural network to learn the model, and it is able to learn the data patterns and it will apply to the unseen neural new data. So here the formula where max j and min j are maximum and minimum values respectively of attribute xj over the training data set. Okay, the data representation is mandatory to feed the neural network to learn some model by the neural network. So that is in the form of continuous data in between the ranges 0 and 1. Okay, the next one is network topology. So how it will be look like, what is the structure, what is the design of the neural network. So to design artificial neural network, there is no fixed static design says that only these rules we need to follow to find to design the neural network, or it contains only one input layer, one output layer and only one hidden layer. There is no such type of rules here. Depends on the situation, it will design the neural networks. Let's see. Network topology may again be considered a problem specific, since the number of layers, how many layers, for example, identifying the digit, then it will require a simple network. For example, identifying the image, then it requires some more complex neural network comparing to the identifying digits. Okay, how many number of layers, how many neurons, it depends on the layers, depends on the scenario. In each layer, how many neurons, what is the depth of that neuron. So it will be purely depends on the task at hand. This issue is resolved by using the trial and error method. So it will follow the two strategies. First one is start from a large network and successfully keep removing neurons and links until network performs starts showing degradation. For example, a statue. First they will build a statue, entire statue. After that they will scalp that statue to look nicely. So it will start from the big and they will remove whatever they don't want. So from big to small. The next one is start with a small network. For example, consider house construction. It will start with a single room. Later it will goes to the next room, like that. It will add the rooms to that house. So in the same way, here also start with a small network and introduce new neurons until performance becomes satisfactory. Then it will stop. Okay, so here the strategy is trial and error proven method. The next one, network parameters. This one is important. The concept of network parameters involve a number of steps such as proper initialization of weights, which means input node to hidden node. Input node to hidden node, there is a weight will be there. So based upon the weight, whether that link is how much important, it will be decided using this weight. The first one is proper initialization of weights. Second one is choosing appropriate learning data. If you choose a low learning rate, then what happens, like a baby steps, slowly it will learn the patterns from the data, learn that model by the neural networks. If you choose the high, means next value, the learning as a learning rate, then it will jumps like fast. It will learn the fast data and it is unable to recognize the patterns in the data. The third one is the training set of examples. The enough training examples are required. For example, if the disease is fever, what are the training examples? It contains temperature. So for this temperature, the weight will be more, because based upon the temperature only we will decide whether the disease is fever or not. Okay, after temperature, some of them will have headache, sneezing, cold, like that. So these are the training set. If the person contains the temperature, certain limit will be there. If it exceeds then the temperature and having headache and sneezing, then it will reaches with the fever. So enough training set has to be there to learn the neural network. Let's see. First one, initialization of weights. Generally, initialized weights are chosen randomly with the values typically lying between -1.0 and 1.0 or -0.5 and 0.5. Next, choice of learning rate. It is in between 0.1 to 0.9, depends on the applications. The last one is training examples. The heuristic that needs to be followed while training is that the number of training examples must be at least 5 to 10 times the number of weights of the networks. It needs to be enough training examples. The last one is training, validation and also testing. You can say a simple example, a student is studying, that is training. Validation, taking a mock test, then that is called as validation. And testing, that is a final exam. If a student is performing in final exam, then that is called as testing phase. Okay, the training process of adjusting weights using training data and back propagation. For example, in the last sessions we have seen a single layer and multi-layer. First it will perform the weighted sum up. After that it will take one of the activation function to decide the whether the neuron is active or not. So if to take the first, it needs to observe the expected output and desired output after weighted sum up and performing the activation function. So there is a back propagation algorithm. In that, it contains the two phases. One is a forward phase and another one is a backward phase. In the forward phase, it will the flow of data is from input to output. In the backward, it will starts from the output to hidden node to input node. So while coming back output node to input node, it needs to adjust the weights using the back propagation algorithm. Delta rule will be followed. Okay, next one is validation. Assessing the model's performance on a separate validation set to avoid overfitting. It needs to take some data to validate whether that model is performing accurately or not. What are the techniques? The first one is cross validation, early stopping and regularization methods. Cross validation means the student performance on different question papers. If he is well prepared for the test, then we can test in the multiple question papers. In the same way, cross validation, it will be performed on the multiple data sets. Next, early stopping. So after increasing the test, then if it is giving error increasing, then we will stop. When adding the multiple values, then if it is increasing that error, then we will stop that one. Next, regularization methods. So after reaching some state, for example, we can say equilibrium, stable state, then we will stop that model also. Okay, so the last one is testing like a final, means unseen data we will give that model and we will see the what is the accuracy, how it is performing, that is testing. Okay, these are the four various designs, four design issues. First one is a data representation. Second one is network parameters. Next, training and validation, and another one is network topology. So in the data representation, the range is in between 0 and 1. It will take only these values, and there is a formula to convert the larger values into these values, and we will feed these values to the data. The next one is network parameters, weights, learning rate, and training examples. Next, training and validation. What is the process to train the model? Next one is network topology. How many layers in that neural network? How many neurons? What is the process? Everything will be decided in this network topology using error and trial method. Thank you.